Hello everyone, welcome to this video. So again we are going to solve the next numerical that is based on the work energy principle. Here in this question you can see here that we are having a cylinder that is having a mass of 20 kg, okay, and that is being released when it is at a height h is equals to 0, means it is being released from this particular position, and we need to determine its speed when it reaches height of 3 meter, that is when it lies at this particular height. So, and again it is given that the unstressed length of the spring is 2 meter and the value of stiffness is 40 newton per meter. Fine. So when this particular cylinder is at this particular location, then since the unstressed length of this spring is 2 meter and the length here is also equals to 2 meters, so the deformation in the spring at that particular location will be equals to 0, means the value of x at that particular location will be equals to 0. Next thing here is that given this cylinder is at this particular location, fine, so we know this is 2 meter and this is 3 meter, so we can work out by hypotenuse law the length of this hypotenuse, and that will come out to be 3.61 meter. Fine, 3.61 meter, and we know that the unstressed length of the spring is 2 meter, so we can have the deformation of the spring at that particular level, that is that deformation x2 we can have equals to 1.61 meter. Okay, so by this way we can have the deformation of the spring at the two locations. So now let's see one by one the deformation in these types of springs. So we can have the two condition here, that let us suppose that this is your position first and let's say that this is your position 2. Okay, so in these both of these position we can have the deformation and velocities at these two individual particular location. Let's say in the first position the deformation x1 will be equals to 0, since that length is equals to the free length of the spring, therefore x1 value will be equals to 0, and moreover v1 will also be equals to 0, because since this object is in a state of rest at this particular location. Fine. Now when next it is at the position 2, then we can work out on this value of x2, that is equals to, by using the hypotenuse theorem. So if we use that hypotenuse theorem, then we can easily get an idea of the get this idea of the x2. Okay, so we can use that formula again, and that hypotenuse is, since it is equals to 3.61, so subtract it by the undeformed length, then we can have this value of x2 equals to 1.61 meter. So by this way we can get these value of deformation and velocity at these two location, and since we need to find the velocity v2 over here, so that will be a known quantity over here, and we will be using our work energy theorem principle to get this velocity at that particular location. Okay, so now let's see how we can use that particular equation here to solve the question. So we will be again using the work energy principle theorem, which says that whatever the work done is here, that is equals to the change in the kinetic energy of the body. Okay, so that at first the work done will be equals to 20, that is its mass, multiplied by 9.81, that will give the force, multiplied by the distance that it has traveled, that is 3, plus, since we are having two spring systems, so just simply multiply it by 2, and strain energy equals to half times of k, value of k is 40, so write down here 40 times of initial x1 is square, so x1 initial is equals to 0, then we have x2 square, that is equals to 1.61 square. Okay, just multiply it 2 times and that will give you um, final kinetic energy minus initial kinetic energy, that is half times of 20 times of v2 square minus of 0. Okay, so from again this equation you can find out this value of unknown v2 over here, and that value of v2 will come out to be 6.9 meter per second. So by this way you can solve this particular question and can get this value of the velocity at that particular position, that is equals to 6.9 meter per second. Okay, so now we will solve the next numerical. Okay, now let's see in this particular question we are again having a two spring system over here, and it is given that these two springs of 100 mm free length each are being connected to each other end. okay, at these two hinges A and as well as B, and the center is at the C of this particular location. And what we are doing over here is that this we have pulled this spring downwards. Okay, so this spring has been pulled in a downward direction, which is having a 2 kg mass at the center, and then it is released such that this particular object is being projected in a vertical direction. So, and it is again given that the stiffness of this spring is equals to 100 Newton per mm, and we need to calculate it the velocity with which this sphere will pass this point C, and then we have to calculate that how far will it rise over C if you use the rectilinear equation of motion. Okay, so again we will be using some we will be just having these two position in this case. So let us say that if this is your position first and if this is your position second, so we will having the velocity at these two positions v1 as well as v2, and at these positions there will be certain deformation as well as velocity over here. So at this particular position 1 here, the velocity will be equals to 0, no doubt, since it is in a state of rest. And here we need to find out the velocity, so that will be an unknown velocity v2 over here. Okay, next at this particular location, if you see, then here the deformation in the spring, that is also equals to 0. Okay, because here the length, whatever the length is, it is 100 mm, and when this ball comes at this when this spring system comes at this particular location, then it is also length is equals to 100 mm. So the deformation x will be equals to 0 over here. But at this location we can find out, if we use the hypotenuse theorem, then this is 100 and this is 40 mm. So we can work out on the formula and can get an idea of what would be the length of this spring system. Okay, and if we subtract the free length from this, then we can have that deformation x1 in this case, which will give out to be total extension in the spring. Here if we get from the Pythagoras theorem that it is equals to 1.077 minus by its free length 0.1, then that will give the x1 value in this case, which is 0.0077. Okay, and the next thing is that the distance that it has traveled during this time is 40 mm. The value of its spring constant K is 1000 Newton per mm. So again, we can use the work energy theorem to solve this particular numerical. So we can write down this work energy theorem equation, so that this work done, that will be equals to the change in the kinetic energy of the body. Okay, so if you see the work done, since the object is moving in an upward direction, so that work done would be negative, so it'd be minus of 2 times of 9.81 multiplied by distance that it has covered, that is 0.04, plus that strain energy in the spring, and that is equals to, since it is two springs, so multiply by 2, it will be half times of K that is given in the question, minus into x1 square minus of x2 square. So the x1 that we have calculated here is 0.0077 square minus of 0 square. Okay, and that will be equals to the change in kinetic energy, that is final kinetic energy, half of mv square, mv square, and initial is 0. So again, there is only one unknown over here, that is v2, and if you solve this numerical, then you can get the velocity v2 equals to 7.65 meter per second. Okay, so the latter half of this question is asking about what is that maximum height that the ball will go when it is being projected from the point C. So we can use that rectilinear equation of motion to get that value of h. Okay, so let me draw that figure again. So let us consider that this is your system and that ball is now at this particular location, and that is it is being projected in an upward direction. So if you want to know that value of h, we can use that rectilinear equation of motion, v square equals to u square plus of 2gh. Find that the final velocity at that apex will be equals to 0. So it will be 0 equals to 7.65, that is the velocity at the point C. Okay, square minus of 2 times of 9.81 into h will be negative. So from here we can solve this question and can get the value h equals to 2.9 meter. So with that is the height that this particular ball will cover when that is being released from that particular position. Okay, so we can solve this numerical like this. Okay, now see the next question. Here in the question it is given a two spring system again, which is, and both of these springs are having different value of stiffness. The upper spring is having the K value of 50 Newton per meter, and the below spring is having a value of 25 Newton per meter, and both of these springs are being rounded over this smooth rod. Okay, so in this case we basically need, and that given that the attached springs are undeformed when this value of t is equals to 0.5, means when this collar is at this particular location when t is equal to 0.5 meter, then there is no any type of deformation in this spring. So again it is given that there is a force of 100 Newton that is being applied at an angle of 60 degree. Okay, and we need to find out what would be the speed of this particular collar when the value of t is equals to 0.3 meter. Okay, so when this d becomes equals to 0.3 meter. Okay, so when this d equals to 0.3, let us say that at this particular location d is equals to 0.3. So whatever the springs that it is compressing this particular spring, so it is being compressed equals to 0.2. How we have got this 0.2? Since you can write here that 0.3 minus of 0.5 minus 0.3 will give you 0.2. So by this way, that spring at the lower end, it is being compressed, and initially that this collar is at a state of rest. So we need to find out what is that velocity when this block reaches at this particular location. So we need to calculate that velocity v2 value. Okay, so again we can have two state at two positions, one position first and other would be the position two. Okay, so let us say that this is your position first, which was the position of rest. Let's say that this is your position first, and let's say this is our position. Sorry, and just a second. At the position 2, let's say that this is our position 2 when that the collar comes to at this particular location. Okay, so again we can have the with these velocities at both of these position 1 and position 2. At this particular position the velocity is equals to 0, as well as compression in the spring x1 is also equals to 0, and at this location of 2 the velocity that we need to calculate v2 over there, and the value of x2 is equals to 0.2, because that is equals to 0.5 minus of 0.3. So that will give x2 value equals to 0.2. And now we can use again work energy principle and can get the values of the velocity at the position 2. So now let's see how we can get that value. So use that work energy principle. So you can write here that work done will be equals to the change in the kinetic energy of the body. Fine, and that work done is equals to, let's say over here will be equals to 20 times of 9.81. Fine, and the distance traveled is 0.2. And next will be the force, external force that is being acting. So its vertical component will be equals to your 100, and in the vertical direction it will be assigned 60 value and multiply by the distance that it has covered, that is 0.2, plus there is a spring in the upward and in the bottom phases. So now we will have that strain energy due to both of these. So let's say that due to first it is having half of 25 x1 square, that is equals to 0, minus of x2 square, that is 0.2 square. Fine, and let's say due to the other spring we are having half of k, the value of k will be 15. Okay, and x1 will be equals to 0 square and x2 will be 0.2 square. Fine, and equate with half mv square, half of m mass is 20 kg, and then we have v2 square minus of 0. So in this case again we are having only one unknown over here, that is your v2, and we can have this value if we solve this equation, and we can have this value v2 equals to 2.36 meter. So when this object is released from the position first, and when it comes to the position 2, then it will have a velocity v2 equals to 2.36 meter per second. So by this way you can get this value. Okay, so in the next video we will see some more numericals on work energy. Yeah, okay.